In part two in our series about value spheres, we're going to take all of those discussions about the diagrams and the disco ball demos and all of that theory, and we're going to apply all of those things to the art of drawing well. The range of possible optical phenomena in the reality that we see is incredibly vast, absolutely infinite. But then the tools that we have to represent that reality are very, very narrow. And so we have to understand those tools extremely well. For example, if we want to represent staring into the sun, all we've got is this. Value spheres are an analog that we use to represent all of observed reality. And so when you look at drawings like these, you can begin to realize that they're simply funky value spheres or value cylinders or value cones. The reason that we practice value spheres over and over is the same reason why good musicians will practice their scales every day. Because you don't want to have to worry about how to play your instrument when a song is coming through you. Similarly, you don't want to have to worry about how to draw while you're creating ideas on the page. And this capacity, this ability is referred to as automaticity. You don't need to have to worry about how to hit a tennis ball when it's coming at you 110 miles an hour. So please refer to the PDF that I sent you by that same title, Automaticity. So before we get started drawing value spheres, let's take a drawing like this. This is a drawing that I did that you guys have seen, and just analyze it. Why is it that this thing looks like an event from real life? What makes it look so round and sculptural and volumetric? And the secret is that there's no secret. The secret is that it's basically a value sphere. So again, let's read across the drawing. So here is incident light. Here's a highlight. And as you drop down here, these values, as the object turns the corner, as it turns away from the light, the values slowly fall off until you reach shadow core. And then beyond shadow core, there's reflected light. This is just a funky value sphere. So once you've described a rectangle on your page, pick a spot somewhere sort of-ish in the middle and very, very lightly trace a perfect circle somewhere within the rectangle. And then, using your same piece of cardboard as a drafting tool, give yourself a horizon that goes right through the sphere. So that'll represent the edge of a table. So next step, choose sort of a virtual light source. So I've drawn this kind of track light up here outside of the rectangle so things aren't too scrunched in. And give it a real direct sense of direction in reference to the circle. Then what I'd like you to do is to draw some reference lines. Now mine are overstated so that you can see them in the video. Yours can be much fainter. I want you to draw lines from the edges of the light source, touching the edges of the circle and intersecting with this baseline that you've drawn on both sides, the upper and the lower. This is going to give us 4 really important points. It's going to tell us where the shadow core is, and it's going to tell us where the shadow begins and ends. So before we get started doing value spheres, or before we do any kind of a value drawing at all, it's good to sort of warm up by doing a gradient strip. And the important thing here is that there are no stripes, no steps, no bands, just one smooth transition. And here I started off with an HB and then moved to a 6B. It sounds like the most obvious thing in the world, but if you take a flat white piece of paper and put an even tone on it, all you've done is to take a flat white space and make a flat gray space. And so here's the whole power of value spheres. Our eyes perceive that things are round or rolling or sculptural because the values are changing. As this object rolls out of the light, those values change in a very, very mathematical, smooth progression. So before we begin to draw our theoretical value sphere on paper, again, let's review the anatomy of light. So I've got this little beach ball that I painted satiny white. I've put it under a light source that's very similar in angle to the little track light that you're going to see in our diagram. And let's review what happens. So here's the light source, and it's smacking down right here. So this is incident light. This is where the light is the most direct. And as this form rotates away from the light source, it's getting hit with fewer and fewer photons until at the edge here, the light particles are just glancing by. And then when you get past this midpoint, none of this direct light can hit any of this backside of the sphere, this backside of the moon. And so all of this is referred to as form light. All of this is referred to as cast shadow. And again, incident light slowly falling off, faster and faster till it gets to the shadow core. And then as you get past the shadow core, all of these other dull light sources are bouncing back. And you can see a nice example here where the table surface is kicking light back underneath the sphere. And then way under here is what we call occlusion crack, where no light is bouncing in from anywhere. The lightest light here is our highlight. And I'll send you another video that really takes into account what that phenomenon is. So the highlight is the lightest light. The occlusion crack is the darkest dark. Everything else is in between those extremes, which is referred to as the gamut. So we're finally ready to draw an ideal value sphere. And again, value spheres are kind of a laboratory for everything that happens in light interactions. If you can do a value sphere, you can do anything. So setting up here, I've done a few things. I've erased most of these lines that just existed to give me the 2 points where the shadow core begins and ends. And then these 2 points, 3 and 4, where the cast shadow begins and ends in reference to that light source. I also mentioned in class that studied with a great painter who reminded his students that sometimes it's a really good idea to just write a list of how you want your drawing or your painting to come out. But this will be your mantra for value spheres. The key words are patience and smoothness. So step one, I'm going to draw the value sphere's shadow core. I'm also going to indicate the occlusion crack and an area where the highlight is. So the highlight is going to be the lightest light. The occlusion crack is going to be the darkest dark. Everything is going to be somewhere in between. So I actually set a timer, and this, what you see here, represents about 3 minutes and 30 seconds worth of work. And you can also see that I put a value strip at the bottom here so that as we go through this, we're literally on the same page. And what I've done here is I've put some really slight tone, maybe like a value 9, over most of light world, but I've left pure paper here where the highlight is. And then our shadow core is kind of blocked in. It's a soft curve. And this little area where the sphere isn't getting any bounce light from anywhere, it's getting the least amount of light here, is maybe a value 6. The occlusion crack, though, down here is a value 10. And then our cast shadow, which is just kind of blocked in, is maybe a value 8. These are just kind of placeholder forms. But you can see already, this is a very crude drawing, but you can see it's already starting to look like something that would happen in the real world. It's really important as you're doing this to have a nicely tuned pencil and to put your tones in very, very softly with these little quick overlapping ovals. And again, think of your pencil more like a paintbrush and less as a stylus. What you're looking at here is about another 5 minutes of drawing. So after I got this whole environment set up in my horizon and box and circle template, that first stage was about 3.5, 4 minutes. This is another 5 minutes of work. And you can see that what I've done, I hope, is that I've kind of deepened and really defined the shadow core. It's not a stripe, it's just sort of like this very defined cloud. It's darkest here at the center, and you can see that I'm starting to get the effect of bounced light here, and there's nothing to bounce light into the sphere up here, so it's a little bit deeper shadow, but not as deep as the shadow core. And you can see that these tones are moving very, very slowly. That's the whole game. It's that range between incident light and the middle ground here that you really have to stretch that out. That's referred to as compressing values, where you have a lot of changes in a small space. So the other truth here is that light world can be a little bit more complicated. Shadow world is pretty simple. So the next thing that I'm going to work on to wrap this up is that I'm going to go into this transition. I'm really going to work this. Some people who draw and paint the figure will actually start with the shadow core, which follows the form, and then they'll roll out of the shadow. That's a pretty nice way to work. You can actually work both directions, or one or the other, or both. But sometimes it's helpful to kind of roll out of the shadows. In order to craft my cast shadow, take a look at this. Just take your pencil under a direct light source and plant it down on the page. That's everything you need to know about shadow. And so now this is about 5 minutes later in the evolution of this value sphere. I took a variety of pencils. I used maybe a 2H, and I really kind of made a soft change from here to there. I deepened the shadow core so that the shadow core at its darkest is maybe 4, not quite a 4. It's more like a 5 to a 6. But it's a gradient. And again, like I said before, the truth of this is, in optical reality, that light world is a little bit more complicated. There are a lot more slow changes and, like I said, compressed values. But shadows are pretty simple. This is a pretty simple gradient. It's a pretty simple gradient out to here where it's not getting bounced light. It's a simple gradient to where it is getting bounced light. The cast shadow, again, is a pretty simple gradient whose edges get softer and softer as those effects get farther and farther away from the object that casts them. And that's pretty much the whole recipe for value spheres. And again, there will be a follow-up, and we'll do some value cylinders and value cones, but you'll see that it's just a formula. It's an elegant formula, but it's just a formula that's easily understandable.